Buckle up because Proof of Podcast has something special for you. Introducing Remedy, the ultimate Web3 cybersecurity platform custom built to propel you to the forefront of the Web3 revolution. Jam-packed with the very best in emerging tech, Remedy empowers blockchains, Web3 projects, and security researchers with innovative tools and services, like Glider, a code query engine that lets you hunt vulnerabilities at the blockchain scale. How? By letting you query specific code in every smart contract on every integrated EVM blockchain within seconds, and also an easy to onboard bug bounty hosting service backed by elite triaging and zero knowledge stack that makes duplicates report a thing of the past. So what are you waiting for? Sign up today at r.xyz and leverage the power of Remedy to supercharge the complete security lifecycle of Web3 projects. How was the jump from Delphi to Nil? Was it something that you kind of started looking at Delphi, or did you get like kind of hunted?
That's a good question. Yeah, actually, Misha might hate me for this. Misha's our co-founder, but Misha pitched me while I was at Delphi, like 2.5 years ago, and I couldn't understand a damn thing Misha was saying. It was clear there's like really interesting technology being built here, but maybe it was just me, but I could not understand some of the terminology that that Misha was using, and later I began to find out that well, Misha was saying words like replication packets and talking about consistency across clusters. And I'm thinking, oh, Misha, Nil is designing some sort of database, and they had this product at the time called Drop Database, which is this DBMS service, this database management service. And me, as a crypto investor and background in blockchains, I was like, what the fuck is this stuff? Well, it turns out Misha was talking about blockchains just using like traditional distributed systems terminology and vernacular. And, as time went on, I sort of maintained our relationship, understood what was being built. And when it came time to make a move, there was really like a natural sort of transition into the role. And the day-to-day transition was quite a shock. I mean, moving from investing to the operating side, and I've tweeted about this a bit. It's drastically different.
Yeah,
And I
I
think,
imagine.
yeah,
Can you give us a little TLDR of it's what was what was he pitching you that you finally managed to understand what he meant in blockchain terms?
yeah. Well, let's see. What? Well, I think what was intriguing at first was the Nil Foundation's ZK toolchain. So Nil, most people know of Nil as maybe a brand that's affiliated in the world of ZK, but they're truly pioneers in ZK, development and research, starting all the way back in 2018. And early work was largely sort of project focused, almost like a consulting like service, working with really high profile projects, had their hands, early development of Lido, did Filecoin mining. They built the first ZK bridges, consensus proofs for Solana. Work with Mina and the EF, and so on. And along the way, they built a few products. So the first product that was intriguing to me, right, as chief product officer, somebody who's thinking about products and selling a product and distributing it to the market, was the ZK toolchain, which is essentially the combination of the ZK LLVM and the ZK proof market. And the ZK LLVM is a circuit compiler, so it takes code, arbitrary code, and maps it into a circuit, a ZK circuit, which you can then use to generate a zero knowledge proof. And you can source that proof generation, that computation, from the zero knowledge proof market. And so this stack, this tool chain, this pipeline is a really powerful tool for ZK, developers who are looking to build ZK applications. That was like the first intriguing thing. But what really hooked me was this view on the market that while there's so many exciting ZK use cases out there today, lots of interesting experiments and even well funded, very competent teams building ZK applications for privacy and ZKML, other types of arbitrary or verifiable compute. The number one use case for ZK today, the clearest market for it, is scaling blockchains. And this I felt was really important. I wanted to solve the biggest problems in the space with the most cutting edge, state of the art technology. And I felt found Nil as a kind of a perfect home offering both.
Right. And were these projects kind of or these products a byproduct of the other consulting work, or was this something that it was a separate vision that Nil Foundation was working on? How did that initiate the was there like a guiding framework that you guys wanted to achieve something, or just did it naturally occur?
It's a great question. I think it's a little bit of both, right? I mean, Nil began as this sort of diehard, like handful of diehard crypto engineers, researchers, enthusiasts, applied cryptographer types, and the vision was to build super scalable and secure virtual machines and blockchains. But this is like a grand vision, sort of, and kind of arbitrary vision for a small group of of people. So to start, the work that this Nil Foundation originally did was helping folks that were building blockchain infrastructure with the ZK development end of things. And along the way, it became apparent, well, if we're going to be doing this development, which in many cases was actually circuit development, writing circuits, well, why don't we build a tool that might help us sort of accelerate this process? And hence the ZK-LLVM, right? The ability to take arbitrary code and map it into circuits. The proof market, similarly, right? These are, especially when the proof market was, birthed as an idea, proof generation, it was incredibly expensive, like nearly prohibitively so. And Nil Foundation had the foresight that this would actually be a really great market to sort of set up in a decentralized setting and allow free market forces to find the best, most efficient price for proof generation. So it's a little bit of both, right? Like there was this clear North Star of building out state-of-the-art ZK applications and tooling, in particular for the application of blockchain infrastructure and scaling and interoperability. And then along the way, as we're doing hands-on work, building out product, right? And I think the culmination of all of that is Nil, the layer 2 that we're building based on ZK sharding.
Right. And how did that business model work of that kind of specific consulting? Were you guys mainly third-party contractors that were paying for your time, or were you guys brought in as part of the internal team of whatever project you were working on at the moment?
It was mostly third-party contract work. Yeah, I mean, I think the way that, and maybe this is a little bit of insight into like the inner workings and operations of, an infrastructure, crypto infrastructure team, especially one that's building out, a blockchain. There are a lot of components that need to be built, especially if you're building from scratch. And, frankly, the many of those components are kind of like one time, like one and done type of components. You also have very often the demand or desire for multiple client implementations, right? So many of these ecosystems and foundations, you might call it, will bring on third-party contractors, teams that have done this for other blockchains or for other infrastructure projects, and they contract this work out. And there's some really incredible groups who do this type of work. Lambda class is a close friends of ours, and they've done this across the board. You take a look at the work that they've done, and they've built like the modern day blockchain stack essentially.
Yeah, yeah. I think it's very interesting because it's such a unique set of individuals that are able to kind of implement this in a reasonable time frame, and especially with crypto that it's so fast evolving. How do you guys keep up with innovation and make sure you get the right talent to keep moving forward?
Mm. That's a hard hitting question. Well, I'll split it into two parts. One, in terms of keeping up with the pace of innovation, I think we're fortunate in that we've developed and sort of like fostered a culture of really thinking for ourselves, and I think that's actually been an incredibly powerful, pretty much instrumental asset for us in being sort of ahead of the curve on a lot of these tools, right? And that the zk-LLVM, a circuit compiler, right, that maps into ZK circuits through LLVM was sort of beyond its time, so to speak, in a time when DSLs, right, were sort of the dominant way in which you would write ZK applications.
Can you briefly explain DSLs for the audience?
Yeah. So, like domain-specific language. So these are pretty much language-level abstractions to build ZK applications. Cairo from Starkware and Noir are examples.
And you mentioned other teams like Lambda as well. Do you guys work together, and there's any, let's say, intermingling of talents between these types of teams?
We don't work with Lambda right now. They're an incredible group. I just think very highly of them. We hosted an event at ETH Denver earlier this year. But no, there's no intermingling of resources.
I see. So you mentioned a few products that New Foundation has developed.
Mm-hmm.
And a lot goes into what people are able to do with these and where these are heading. So can you give us a bit of a overview of what New Foundation has in its hands right now and where it's planning to take this as a whole package?
Yeah, definitely. So Nil Foundation, I think of Nil as having two core products. One is the ZK toolchain, which I had mentioned, right? The combination of zk-LLVM, a circuit compiler, and the proof market, a marketplace where you can source proof generation. And this is an incredible pipeline for developers to build, again, arbitrary zero-knowledge applications. The other side, the other product, is what we're developing, and that's Nil, and a horizontally scalable Ethereum layer 2. And that's powered by ZK sharding, a blockchain architecture that we've designed. And we believe this is the most scalable in the sense of like global scale layer 2 blockchain. And we borrow a lot of work from sort of old Ethereum efforts for sharding, Near, Ton, lots of well-studied distributed systems research, and bring these techniques to the layer 2 landscape. And the result is again this hyper scalable, globally scalable layer 2 that maintains this single notion of state, a single network, and we think this is critical. And in particular, we think the emergence of these, what you might call hyper-scalable layer twos, are critical for the Ethereum ecosystem at large. And we can talk maybe a little bit more about that, but I'll pause there.
Yeah, I really want to get into the L2 subject, but can you speak a little more in depth about how does the sourcing of proof generating works? Like, what are the different components of this mechanism between sourcing proof generation from different places?
Mm-hmm. So when we were talking about sourcing proof generation in the context of Nil Foundation, we're typically talking about the proof market, right? Nil Foundation's proof market. And the proof market is really, you can think of it like a decentralized compute marketplace that's just so happens to be bespoke for zero knowledge computations, for zero knowledge proof generation. But it's really just a marketplace, right? It's a buy and sell side marketplace where the buy side are applications who are looking for proof generation, and that could be developers, it can be other pieces of infrastructure, and so the sell side, the supply side, are those who have hardware, right? And we believe that, and we're already seeing a lot of incredible progress being made for ZK specific hardware optimizations, right? And this is happening at with GPUs, but also all the way on the other side of the spectrum in ASIC development. And the proof market is a place in which these these folks who own and are developing this specialized hardware can actually offer it to a demand side. When we talk about ZK sharding and we talk about Nil, the L2, right? There's proof generation demand that is generated from this network, right? And that is fed into Nil Foundation's proof market, which ultimately actually lives as an application, a marketplace application on top of Nil, the L2. So there's a little bit of like this recursive dog feeding, stuff going on. But I hope that makes sense. Yeah.
It makes sense. Yeah, at least for me, it does make sense. So at the most basic level, it is basically a computing marketplace, and people that have good hardware for ZK are there trying to supply it, and people that need proof generation are bidding for different hardware suppliers.
Yep, exactly. Yep.
And now moving on to the L2s. There's a lot of L2s, right? There's no shortage of L2s nowadays. And that's good and bad in a lot of ways. So why did you guys decide to go for yet another L2? I imagine you have helped design a lot of systems for L2s. So what made you decide that we're going to launch an L2? What can you do that's possibly so different from what's already being built by many teams at a very large scale that you still felt confident enough to say, we actually have a better idea or a very different idea, and we think it's worth a shot, even though there's huge competition?
Mm-hmm. Yeah, it's a great question. I mean, you sound like a good investor asking that kind of question.
I wish.
I mean, listen, one day soon. Listen, I think ultimately, and I'm not shy to say this, I mean, we believe that there is still a lot of room for the layer 2 ecosystem to mature into. In particular, we believe that layer 2s, most rollups, including the most popular ones today that have billions of dollars of TPL, have not done the appropriate job of scaling the L2 itself. And I think what's needed here is a little bit of nuance in terms of what do I mean by scaling, right? And in a very traditional setup for a roll up, you pretty much take a naive implementation of the EVM and you run it on a centralized server. You process transactions, batch them, and then post them back down to the L1. Now, all you've done is built this batching mechanism, right? You have not actually scaled the EVM. You haven't scaled your execution of that L2. You haven't scaled the ability for that L2 to manage growing state. You've simply just built a new, very naive implementation of a blockchain that batches transactions to another blockchain and gets some sort of settlement guarantees out of it, right? And in the context of that, the layer one's blockchain, the base layer's consensus, if you use that as a reference for scale, you have scaled, right? Because that consensus that for the layer one blockchain now can verify that everything happening on the roll up happened correctly, right? So you have this scaling of consensus guarantees, but you don't actually have scale the layer two at the layer two level, right? And this is where we fundamentally think there's a lot of room for layer twos to actually grow into, and I think it's a very nuanced conversation, and I think people have kind of opted for this framework that modularity means scale, or and this is how we scale a blockchain is just modularity, but fundamentally modularity doesn't mean scale. It has nothing to do with how a blockchain increases its capacity to handle increasing loads or throughput. And in the same vein, this modular versus monolithic debate is kind of lost because neither of them inherently say anything about how you scale a blockchain. And so we're very big proponents, and I'm sure you've seen some of the stuff that we've done of shifting the framework on how we think about scaling blockchains to vertical and horizontal scaling, which are tried and true, very legitimate ways in which you scale blockchains or distributed systems. And we think that both of these techniques, vertical scaling and horizontal scaling, have not been played out at the sort of layer two level. And this is kind of where we see Nil fitting in particular, taking a horizontal scaling first approach and bringing a true sharded blockchain to the Ethereum layer two landscape.
Right. So there's definitely a lot of ways or a lot of perspectives which you can call a blockchain scalable or scaled or not scaled. So can you give us a hard example of an instance where a blockchain would be considered scaled and one that wouldn't be considered to be scaling?
Sure. Yeah, I mean, absolutely. And I think you made a good point here, which scaling is a relative term. Like you need a point of reference in order to measure scaling. And so I think it's really important to pick, your point of reference. Again, the classical frameworks for scaling distributed systems and also, blockchains is vertical and horizontal scaling. Vertical scaling is essentially a technique in which you increase the capacity of a single machine. So you boost the power of a single machine. And you can do this by, say, just increasing the hardware requirements or increasing sort of the hardware available. So, a very popular way to do this is adding additional cores to a CPU, right? This is a form of vertical scaling. And you can, at the software level, increase hardware utilization, right? So that your software, your, say validator node is taking advantage of more of the hardware that it has available to it, right? This is a vertical scaling technique. And a very concrete example of this is the parallelized virtual machines, right? So Solana, Monad with their parallelized EVM, Eclipse even with their implementation of the SVM, Aptos, Sui, right? These are all traditionally vertical scaling techniques.
And what do they fail to achieve?
Well, this is a good question. They right now are doing an incredible job in stepwise improvements towards performance and in particular speed, right? Now that you're running and processing transactions over more cores, right? Over essentially, more hardware available to you, you're able to process these things much, much faster, right? And the fact that you can do it faster gives you sort of the ability to handle more throughput at any given second or over any given interval. Now, where they're going to run into problems, and they already do, is you're confined by the limits of a single piece of hardware. And this is I think this is another nuanced but really interesting and important point about blockchains, is blockchains are essentially designed to fit into a single machine, right? Even though you have a distributed network of many machines, right, and machines kind of using equivalently here, validator nodes, your processing, you're pretty much like your bottleneck is that of a single machine. And where horizontal scaling, sort of conversely, really shines is that you distribute the workload across many machines. So now, rather than being sort of confined by a single machine, you get the power of many. And traditionally this is done through various sharding protocols and algorithms. Now, one last point is these techniques, they don't inhibit one another, right? So just because you use some form of horizontal scalability or you implement some sort of horizontal scaling technique doesn't mean you can't vertically scale, and vice versa. Now, there is an argument to be made that, maybe moving from, focusing on, a vertically scalable single machine blockchain into a sort of sharded blockchain backend protocol and consensus, that's maybe a more difficult transition than starting with a sharded protocol and consensus and implementing, say, a parallelized virtual machine on top of it. But this is like a very sort of forward-looking, nuance and detail. The point is they both need to happen. They both will likely happen. The end state of blockchains will be a hybrid of both. But these are very clearly different ways in which you scale a blockchain.
So when you say blockchains are supposed to fit in a single machine, do you mean the nodes act as a single machine? Can you explain a little bit more what you meant by that definition?
Yeah, so you think about like just like stripping away all of sort of the modern implementations of blockchains, right? Like, let's just come back to like the basics. You have, right, you have validators, or you have these nodes, let's just call it miners. We'll go all the way back to proof of work, right? You have miners who are all competing to build this one block, right, at any given slot. And you have essentially a bunch of redundant computation to build a single block, right? You don't have this sort of partitioning or distribution of workloads across multiple machines. You have everybody trying to build this one thing. And only one person, right, is going to build that block. So you're essentially bottlenecked by a single machine, right? Because you have a single slot.
I
now,
see.
Does that make sense? Okay.
Yeah, but please go on.
Well, I was just going to, continue, forward. Now, if you actually shard your system in that you sort of split out the state, if you have, imagine you have a global notion of state, right? You now partition that into sort of sub or local states, and you assign shards to, which are essentially a collection of validators, a committee, to each of these shards. Those shards can be run and build blocks in parallel with the other shards, right? And this is the sort of power of horizontal scalability and sharding, is that you get this. Yeah, I don't want to use the word parallelization, because it's so tied to like the parallelized virtual machines, but you do have this parallelized processing power that you can take advantage of.
And why not implement that architecture in an L1? I know it's not a very straightforward, simple answer, but if you can give us a TLDR.
Yeah, I mean, you absolutely could, and projects do, right? So near, they have a sharded protocol. I think they have now 6 shards. Each so you essentially have this global notion of state, and they're, each shard manages 1/6, or, you can kind of think about it like that. Ethereum is implementing dank sharding, or eventually, and this is a form of sharding. You have Telegram Open Network that implements sharding. So sharding, you can certainly implement it at the layer 1 level. Where the reason that we're implementing it at the layer 2 is, one, we see that layer 2s within the Ethereum ecosystem have not sufficiently scaled, right? And we see this as sort of a hole in the market, building these super scalable L2s. And two, we really believe that Ethereum is like the future of blockchain settlement, in that it does not make sense for us to try to bootstrap all of our own settlement in order to build a new blockchain, when we can sort of use and utilize, frankly, the existing Ethereum consensus. Ethereum is hands down the most decentralized, most operationally resilient, programmable blockchain, and we need an arbiter of truth in order for our network of shards to run correctly, right? Everything needs to be verified eventually by that arbiter of truth. And so we really think of, in some ways, we think of Nil and Nil Network as like a sharding extension for Ethereum, where Ethereum is the grandfather shard, right? The shard that is the arbiter of truth. And then you have just many shards alongside it, that are processing transactions, in parallel, and doing things, processing transactions quickly at low cost. So
Do you
that's why
think?
a layer 2. Yeah.
Yeah, I think it makes a lot of sense. Bootstrapping an L1, it's a lot of work and makes it so much of a bigger challenge. But if you assume that at some point there's going to be some sort of Ethereum dank sharding, why even bother having that kind of architecture in an L2? Wouldn't that become, let's say, redundant? Why does an L1 in that architecture still is limited with that an L2 can overcome?
Well, in L2, I think this is actually a pretty simple, there's really just like a very simple point here, which defines like what an L1 can do and what an L2 can do. An L2, frankly, can just move much faster because it is not hindered or slowed down by the development of a layer 1 protocol, right? In that over time, these base layers become ossified, and that's not only from like a, what you would think of traditionally like ossification of technology, but also the process of development. So you'll see that, and we already do that, Ethereum, and rightfully so, is more conservative in how it develops the core Ethereum protocol, right? So changes to the EVM, the core, the EVM that is specifically implemented at Ethereum core, it sees a much slower development and innovation cycle than what you should see at the layer two, right? And so you have this advantage as a layer two to be more experimental and frankly a little bit more aggressive in how you develop your blockchain.
I see. So, in other words, basically, an L1 technology would never be able to catch up to an L2. So there will always be a reason for L2s to exist because they're always going to be advanced to some respect in comparison to Ethereum or other L1s.
Well, so you know, not necessarily. I mean, I think like generally, yes. I have a view that layer twos will continue to be and probably will always be you know the market in which you see innovation for new blockchain designs and architectures. That's not to say that, right, if you go and spin up your own L1 that you can't do innovative things. And I think Monad is a good example of this. Right there, I think you could pretty reasonably say they're doing some innovative work on parallelizing the EVM and some database optimizations, and they're now one. Well, the trade-off there is they don't inherit any sort of security or shared consensus or shared settlement with Ethereum. And this is where I think probably our views are a little bit different in that this is a critical component of our stack. But we still believe that there's lots of room to innovate, right? And so I think it's just a matter of preferences and probably also a little bit, where do your philosophies lie, right? What are your values? What kind of core tenets do you want to build around? For us, decentralization is critical, right? We designed to be decentralized, for example. And this was actually why building a traditional roll-up in the sense of a single sequencer, a centralized sequencer that is just processing and batching transactions was not attractive, right? And if you imagine a collection of roll-ups, right, all running single sequencers, but then now sharing some sort of consensus layer, you ultimately end up building a pseudo sharding like blockchain. And if you actually just accept a sharded blockchain architecture, there's all kinds of interesting optimizations that you can make that you could never do in this sort of collection of single sequencer rollups. In particular, we can have a global validator set, and that validator set can be randomly sampled across shards and sort of have this shared consensus plus randomness that allows for greater decentralization and censorship resistance guarantees. We can also optimize how state is stored and managed across shards. So because it's one single network, we can actually say move the state from shard A to shard B depending on the load that the network is bearing. So we just think that this was like a really clean first principles approach to building a blockchain. And it just so happened that based on our values and our core beliefs, it was critical that Ethereum was the settlement layer for us.
Right. So it could have been an L1 in a parallel universe, but it just ended up not this time.
I mean, I think that's the right way to look at L2s, actually, right? I think the right way to look at all L2s is say, well, if this was just another blockchain, right, like how well would it fare? And right now, all of the rollups are simply single sequencer centralized machines. They're not blockchains. And you know, I know that this was, there's been a lot of debate about roll-ups and the roll-up centric roadmap, but I think that it's healthy that the layer two ecosystem also begins to evolve into exploring these other architectures that maybe aren't as consensus view into like what is the right way to scale. Because if we want decentralization at the layer two level, if we want censorship resistance, we need new designs. And if we want scale, right, we need new designs. And this is where Nil plays.
So ideally, Nil would be, I don't want to use the word infinitely, but a lot more scalable than the current solutions, because the load would be distributed in different machines rather than just depending on one machine, and that would allow for things to be a lot faster and carry a lot more load. Did I get that right?
Yeah, I mean, the one correction is Nil will be a lot more scalable than existing roll-ups that naively implement a single sequencer sort of architecture, right? We effectively have the power of thousands of roll-ups embedded into this single network.
And I know you also have some thoughts on how the current state of roll-up fragmentation impacts the ecosystem overall. You have to make all these decisions of what chain you're going to deploy on and what protocols you're going to interact with. And with Nil, you would be adding up to that roll-up fragmentation. And it's a bit paradoxical, I think. Can you
Yeah.
can you first let us know your perspective in your own words, and then kind of answer me in a way, what do you think, like how do you deal with this kind of paradox?
Mm-hmm. Yeah, I mean, it's a classic pitch of like, oh well, if everybody just like does this thing or like moves to this thing, then things work a lot better, right? But I mean that is the pitch, right? Like we yes, in practice, when Nil is a new network alongside of the many L2 networks, it is separate from the existing ones. The difference is Nil is far more scalable, orders of magnitude more scalable than the existing ones, right? And fundamentally, we believe there's really only two outcomes here. There's two paths. One is you glue essentially the existing state of L2s and rollups back together into a single system, right? And you establish one system by sharing some sort of consensus layer. And this is effectively the work of shared sequencers, right? In that you have rollups buying into a shared consensus layer. This shared consensus layer is offering some sort of guarantees about ordering, sometimes checking execution. Granted, we don't have real-time validity proofs, and allowing for this seamless, arbitrary cross roll-up communication, right? And this is critical. Like when I say gluing everything into a single system, I'm talking about two very particular features of that system. One is some sort of shared consensus, right? And two is the ability to arbitrarily call state across that system, right? And this is actually a really difficult thing to do if you have existing systems that are completely isolated, right? You need to coordinate not only technically and deciding on cross roll up communication standards, transaction formatting, but you also need to work through the political mess of coordinating many, many stakeholders to agree to these standards, right? And to agree that they're streamlining upgrades such that when rollup A upgrades, rollup B, C, D, E, and F, they all understand what that upgrade brings with it. And so does the shared consensus layer. Um, the other route that, again, this is the route that we take is, well, you start new, right? And you sort of say, okay, this is, if we all agree, this is the end state of blockchains, of blockchain architectures. Let's just build it that way from the start. And if we do, we get these benefits, right? We get the benefit of having an integrated developer experience. So we can maintain this network, and we can abstract away this notion of shards. So for an application developer, all you do is deploy your contract. We can optimize, again, how state is managed across this sharded network. And we frankly, we internalize all of the complexity of building a globally scalable, horizontally scalable system. And the system here is Nil the L2, and allow developers and users to simply just use a network that will serve their needs in perpetuity.
So the very little ambitious goal of Nil is to basically be the L2 to dominate them all. Basically, it would be so much better that there would be no reason for others to use any other L2s. And in an ideal world, all the liquidity would merge in Nil. Everything would be interoperable, all the protocols, all the users, all the development, everything would just be concentrated in one L2, and that would allow for better markets, better innovation.
I wouldn't go as far as to say I don't like there's no silver bullet, right? There's nothing that solves everything, right? There are clearly trade-offs to every design decision. In the case of Nil Foundation and how we think about Nil, we certainly believe that most of the activity that you see on top of blockchains can be serviced by a single layer, by a single network, right? Namely, I think Solana is a great case study for just that, in that you have a general purpose, execution environment, you have sort of the scale and costs that is attractive for all kinds of different use cases, and you see an isolated ecosystem or rather a self-contained ecosystem of applications, right? You saw this previously with Ethereum, right? You didn't have the scaling piece. We think this is, it's not that we think, this is 100%, this is possible. You can do this. You can build these systems that are able to handle, global demand, but you need to kind of leave the consensus view of how blockchain should be designed. And in particular, really adopt the methods that are implemented at virtually every single big tech company or high load, software company today. And that is, in particular, sharding. You need to shard your database. If you don't shard your database, you are always confined by the constraints of a single machine. And you are not going to run, well, you may be able to run, say, the New York Stock Exchange on a single super powerful computer. And ultimately that ends up with a very sort of centralized network of computers or of operators. You're not going to run the New York Stock Exchange, Stripe, CME, Venmo, PayPal, etc., all of the world's finance on a single machine. It's ludicrous. So we think that we can handle, right, most of the demand. But That being said, there's absolutely, I think, going to be use cases that want to make alterations to, their virtual machine or to their execution environment. They might want to, alter the fee model for some reason. There may be, private, certainly privacy applications, right, that need to like kind of have this layered or separate, customized, state machine. So I think the way that we see it playing out is you see this power law distribution, right? And most of the activity, like 80% plus, is happening on these general purpose layer twos and just blockchains, period. Um, and then you see a long tail of what you might call app specific, customized chains or L2s or roll ups.
Yeah, that was a very cool analogy. Um, and you mentioned there's no silver bullet. So outside of these, edge cases or privacy edge cases, what would you say is the biggest drawback or the biggest trade-off that Neo has to make to achieve what it is achieving?
Hmm. Well, um, the the biggest and clearest one is a trade-off that fortunately end users don't have to bother with. And that's just the internalization of complexity, in that this is a far more complex protocol and network to build than any of the existing layer two architectures. There is a whole lot of complexity that you have to manage in how you manage cross shard transactions and calls. There's also a significant amount of complexity in how you manage the random sampling of your validator set. Um, there is a lot of complexity in how we build our circuits that verify the execution of each shard to ensure that the entire network can be verified by Ethereum. Um, so there's all kinds of complexity that we have to manage inside of the protocol, right? And as an organization. Now, if
Mm-hmm.
we manage all of that complexity, we end up with like a really great product offering or product experience. Um, there is one core sort of product experience difference, which is the existence of asynchronous calls. Right, in that in a sharded blockchain, calls across shards, say from a smart contract on shard A to a smart contract on shard B, they have this networking overhead in which you have to pass a message between these two shards. And this is inherent to a sharding protocol. It's inherent to any cross roll up or cross chain messaging. Um, Fortunately, we're able to internalize that messaging into the protocol itself. But in the early days, it will be exposed to developers to actually be thinking about these asynchronous calls. And this does present, a new programming model, you might call it. And so this is one of the trade-offs. Now, fortunately, it is possible to build abstractions on top of asynchronous programming paradigms to be more similar to the synchronous programming paradigms, right? But that's, again, another layer of complexity that we need to internalize. Um, all in all, though, these trade-offs are worth it because we end up building a globally scalable, provable, and decentralized layer two blockchain. And we think that complexity is worth it.
So right off the gate, Neo wouldn't be um, EVM equivalent. You couldn't just drop a smart contract on the new blockchain because there will be some extra things you'd have to consider, and eventually, gradually, that would not be the case anymore. Is that correct?
Not. I mean, sort of. The You could run, EVM, an existing, Solidity smart contract built for the EVM on Nil, no problem, right? That is kind of like uh, product requirement number one. Uh, the uh, Nil runs a modified version of the EVM that essentially allows two EVM state machines to communicate with one another asynchronously, right? And that is effectively how we unlock sharding with the EVM. And there's a bunch of work that the Ethereum research community has done around how that might actually be implemented. Um, the and importantly, Nil will be compatible with all of the EVM developer tooling that you could want out of the box. Hard hat, MetaMask, support for Alchemy, and there really shouldn't be, or there won't be any problems there. All of those tools will be out of the box. Where you may want to really start, if you're a developer and you really want to start digging into squeezing out a ton of performance out of this new fancy shiny thing, you're gonna want to sink your teeth into this asynchronous programming, right? And this is not a new concept. This is how the internet is built. It is built off of asynchronous programming, and again, we think this is the future of where blockchains are heading anyway. This is already how rollups are building and architecting their systems, and that they have these essentially asynchronous calls across rollups. And if you believe in this apps, this thousands of app specific rollups universe and future, well, you are living in an asynchronous world. Um, Again, we think that if you internalize that asynchronicity and you internalize the networking and communication overhead, you're actually in a much better place to solve it.
Right. And how would that asynchronicity um, help developers optimize their programming, get the most out of the network? Can you give us an example of a situation where a developer could choose to use async capabilities to make some application easier, better, faster?
Um, Sure. I mean, so let's just take, for example, various, pools, liquidity pools, right, in an AMM, right? If you wanted to, you could deploy separate pools over separate shards, right? And you would effectively have parallel processing of those pools, right? Because you can process each shard independently of one another. Um, Now, would you now that then introduces an interesting design space for cross shard routers, right? Or routers, just period. And in Nil, we have enshrined PBS, which we think is a really interesting design space for these cross shard transactions, right? In that you can have these agreements between proposers of each shard with mega builders who are able to facilitate these, these, synchronous or atomic cross shard transactions.
I see. That's interesting. But it makes me think instantly that with all this complexity, um, it obviously comes the security trade-off, especially on the blockchain level, not even on the application level. You mentioned that it's significantly more complex than any blockchain existing at the moment. So how do you tackle this challenge of complexity in the security side of things? And in that as well, it kind of makes it a lot harder to upgrade the system or update the system, because I imagine every change that you want to make would be a lot more complex as well. And wouldn't that kind of defeat the purpose of that thing that we talked about before, of the fast pace of innovation and updatability of the L2s? Wouldn't that be a drawback in that sense, that you wouldn't be able to move as fast as you want because you have all this complexity they have to take care of, and that's a lot harder to secure properly?
So this is a good question about, you know, what, yeah, what is complexity actually, what is complexity's impact on our ability to develop, right? Or our development speed. I mean, frankly, we've developed some of the most complex products, I think, in the market. So fortunately, we have like a very talented team who's, who's done this before, right? The other point is complexity in this sense doesn't necessarily equate to insecurity. Like that is unequivocally not true. I mean, we run a decentralized consensus over that is a global validator set with random sampling, right? So we chunk into committees at random. Those committees are assigned to a shard. They run a fast BFT consensus, right? Just like you would do in with a shared sequencer or an L1 blockchain, right? So you have decentralization guarantees at the shard level. You also have baked in this random sampling variable, which allows us to effectively have better, censorship resistance guarantees than if we were just taking a committee of 5 and saying, you in perpetuity are responsible for this shard. And we also have ZK proofs, right? Validity proofs that are generated every n number of blocks over each shard to verify that the last n blocks were executed correctly. So I don't, I think it's not true that this is like in any ways less secure. In fact, it's likely more secure than any existing layer 2 today. And again, we're ZK developers, engineers, and researchers. Like security is what we live and thrive on. In terms of speed of development, though, I think that's a fair assessment, right? Like this does require us to consider more things as we make each upgrade. But again, ultimately, this is, we think this is necessary. Like this is a complexity that is necessary somewhere. Like you can't just like get rid of it, right? And in the other context, you're trying to manage this complexity across thousands of independent stakeholders and parties working across a number of different technology stacks, which I think is a totally that should be done. There should be people working on that. It's just that also introduces a type of complexity that I think a lot of people overlook, which is social and political complexity, which is far greater than technical and engineering complexity, right? These are engineering problems. They're not even research problems. And engineering complexity is really easily mitigated. Social and political complexity is a nightmare. And, I think there's a lot of really great work being done towards that route, but we believe it's better suited to be, strictly engineering complexity with sort of in protocol social and political dynamics.
Yeah, I agree that if we were to take the route of gluing all the existing rollups, it would be a lot harder and it would be even more risky because you probably would be subject to the most vulnerable chain. The weakest link in the chain could halt the whole thing or bring the whole thing down. So in that sense, I think it is definitely a better approach to start from the ground up. But I think it's also important to think about the two types of securities of blockchains have the economic security, making sure that um, just someone that doesn't have a lot of someone needs a lot of stakeholder power to actually do something nefarious to the consensus. But on the other hand, as well, is the implementation of such consensus and all its parts. That's where things get tricky and some things can um, get overlooked. We've seen even Ethereum had his DAO hack back in the day, and I think it's just part of what we're trying to build with blockchains. It's a unavoidable sort of aspect of the whole thing, and the best we can do really is test it as thoroughly as possible.
Mm-hmm.
And I guess a very complex system is just a very enticing opportunities for hackers because they know where complexity lies, is where there's more chance of unforeseen circumstances happening. So I think these are two different things: the economics, the economic factor, and the, let's say, code vector. But I don't think that's exclusive to any one blockchain. I think they all have this problem, right?
Mm-hmm. Yeah.
And if you had to choose one L2 beside Nil, what current architecture are you the biggest fan of? Which one do you feel like is tackling this scalability problem the best way?
Well, I think that, well, I mean, I genuinely believe we're building, the best place for globally scalable decentralized applications. And if you want to build that, Nil will be the best place to build it. Um, and I'm no longer really in the business of, picking horses anymore. But like from a technical perspective, I think parallelized execution over a single machine, like parallelized virtual machine, I think these are really important areas of development. Um, I think, to name a few names, I think Starknet just announced they're implementing block STM. Eclipse is doing their work with the SVM, and I think there's probably going to be some L2 rollup like implementations of parallelized EVMs. So I think these are all like really great directions. And for what it's worth, a direction that I think will likely take with Nil eventually, in that we implement parallelized execution intra shard, so over one shard. Um, and hopefully these teams that are pushing those areas forward, right, build a body of work that we can draw inspiration from eventually. Because I do think those are clear stepwise improvements in your processing speeds and performance of a blockchain. So yeah, I think a lot of the hype is probably substantiated or is substantiated.
Yeah, cool. And how far deep in development is Nil at the moment? What stage are we in?
Yeah, good question. So Nil has actually been in development for a while. And I mentioned, like in the beginning of this episode, one of the products Nil had built was Drop Database, which was this DBMS service for um, enabling trustless communication and interoperability between different blockchains through this replication protocol. And this protocol, within it, core was state partitioning, aka sharding, and this effectively turned into the foundation for ZK sharding. It was also, the foundation for what was originally where the proof market as an application was running. And now we're approaching a point where, this year we're going to open up for a test net. And, hopefully, come the end of the year, beginning of next, we have actually a mainnet, version one mainnet that developers can use and deploy onto.
That's awesome. And do you have a ballpark on what month the testnet would be live?
Well, one of the first things I learned about moving to the operating side is you never give dates. So I'm not going to give dates here, but Q4, Q1, right, of this year, next year, we're looking at our mainnet launch. Much sooner will be our first versions of testnet, and we'll roll out the traditional private testnet and invite some developers in, get them to come in, poke our thing, break it, find the edges that need some polishing, and then release it to a broader group.
Yeah, no, that's very fair. I'm really excited to see you guys launch and see what you can do because, like you said, it's something that's different from all the other architectures that are happening at the moment, significantly different. So that's really cool. It's a fresh perspective, whereas most of the other L2s are a lot more similar to each other. So I'm really keen to see this go live. So yeah, man, thanks for coming by. It's been a really fun talk. Thanks for showing up.
Yeah, dude, of course. Thanks for inviting me. And yeah, I'm excited to get this thing out. We're heads down. We're hiring, by the way, if anybody's listening and is looking for, join a new company and it's building, some interesting stuff, pretty much across the board, engineering, ecosystem, growth, DevRel, and yeah, keep an eye out. We'll have a few things that we're releasing over the next few weeks, even months, that will hopefully give people a better understanding of what we're doing. But I really appreciate you giving me the time to give my pitch and share a little bit more about what we're doing at Nil Foundation. Thanks.
No worries, man. It's been a blast.